Hi, good afternoon. I'm Mark Kai, and today I'll be discussing to you a circle. Back in elementary, we had been studying what a circle is, like how does it look like and how is it of being used. Now this time we're going to upgrade. In the concept of analytic geometry, circle is actually known to be a conic. When we say conic, it's actually an equation that is derived from the intersection of the plane and the cone. So circle as one of the conics is actually an intersection of the surface of the plane and the cone via right angle. So to formally study that, we are going to discuss first its formal definition. So this is a circle. I hope my penmanship is actually clear for you. So a circle is a set of points equidistant from a fixed point called the center. Okay. So take note of this. Keywords are you have set of points. So infinite number of points. So those points are actually equidistant from the so-called center, which is the fixed point. So suppose for example you have set of infinite number of points here. So let's and say this is the fixed point or the center. So let's say if I pick a point here, let's say p sub 1, and I pick a point here, p sub 2, the distance from the fixed point, the center, to p sub 1 is actually the same as the distance from this to p sub 2, something like that. So even if I pick another point, let's say p sub k, then the distance from p sub k to the center is actually the same as the distance from the center to any points we can find on the circle. And additional definition is that the line segment, or let's say imaginary line segment connecting to a point to the center, to any point that's to the center is called the radius. So to avoid ambiguity here, I'm using the term line segment is actually to express that it's actually the distance from that center to any point of the circle. It's actually not you're going to create a line in the circle. So this, the imaginary line segment, the imaginary line segment connecting to this point is actually the radius. Another here is a radius. In plural, we say radii. Okay, now what happens if I say, I pick here point p sub k. Let's say p sub k. This peak p sub k, we have an imaginary line segment connecting from p sub k to p sub 1, passing through the center. So this line segment, imaginary line segment, is called a diameter, which implies that a diameter is equivalent to twice the radius. Okay? So I'm going to provide you discussion on how to get an equation of the circle. So let's just say we have a plane here, we have a circle here, and we have a point here. Let's say I label this point as HK. Okay. So provided that you are given a point on a circle, at least one point on the circle, let's say x sub xy. Observe that as being defined, a radius is actually the line segment, the imaginary line segment connecting from the point xy to the center hk. So in other words, the radius is actually the distance from this point to this point. So by a distance formula, r, the radius, is actually the distance from these 2 points. So by a distance formula, I can write this as x minus h squared plus y minus k squared. So I remove this d here. So taking the square of both sides, I'll get r equals x minus h squared plus y minus k squared. And this is actually the standard equation of the circle. So just the basic. Let's say, for example, what happens when the circle has a center at the origin? Let's say this is a circle and the center here is the origin. So simply our hk is equivalent to the point 0, 0. So our hk here is 0, 0. So substituting h and k here, we will get, it should be r squared here. So we will get x squared plus y squared. And this is the equation of the circle having center at 0, 0. So it just matters now what's the measure of the radius. So let's say, for example, find an equation of a circle with a center at the origin and a radius of 3. So something like the radius is 3 and the center is at the origin. See? It's just simple. You just copy this here. X squared plus y squared equals 3 squared. Or x squared plus y squared equals 9. So this is actually the standard form of a circle. If you are going to ask, how can you write the equation of a circle in a general form? So you just write this in this way. That's it. Okay, this time we're going to solve problems involving equations of circles and so on, anything that is related to circle. So let's consider this problem. Find the center and the radius, of the circle given by the equation, let's say x squared plus 4x plus y squared minus, let's say, 7 equals 0. By the way, before I proceed, even if I don't write anything here like circle, or I don't give the hint to the problem that this is a circle, you can identify by just looking at the degree of the equation. The degree of x should be at 2 and the degree of y should be at 2. Otherwise, we will be dealing with a different set of equations, or we will be dealing with another conics. So here, we are going to take note that x here, which is, the x squared here, which is the highest degree with respect to x, and the y here has the highest degree with respect to y, should be both positive. So here, so this is now the problem. Find the center and the radius of the circle given by this equation. So in order for us to solve this, we're going to rewrite this equation here. Let's say solution. So I will formalize the solution. Note that x squared plus 4x plus y squared minus 7 equals 0 can be written as x squared plus 4x plus y squared equals 7. Okay? Now, remember that the equation of the circle is this way. Your h and k, your point hk is actually the center of the circle. So in order for us to copy this format here, we can make this into a perfect square. This y here can also be a perfect square. So this is with respect to x, and the 4 here is the coefficient of another x. So in order for us to do that, we are going to complete these terms here into perfect square. So observe that x squared plus 4x, I can add here 4. And this is y squared. But since I add here 4 here on the left side, I should add 4 also to the right side to preserve the equality. Otherwise, this is no longer anymore the same as this. Okay. So these terms here is actually now a perfect square. So if we factor that out, I can have x plus 2 squared plus y squared equals 11. So remember that y squared here can be written also as this. Y minus 0 squared equals 11. So I shall have x minus negative 2 squared plus y minus 0 squared equals square root of 11 squared. So therefore, this is now my h, this is now my k, and this is now my r. So therefore, the center is negative 2, 0. And the radius is square root of 11. Although I took the square root of 11, so I shall get positive or negative square root of 11. Since we're talking with the radius, and the radius is defined as the distance from a fixed point or the center to any point of the circle, then we're dealing with a positive measure. This is actually now the radius. So in order for us to graph that, I'll just give you a hint since I don't have a graphing paper here or a graphing board here. So I'll just show you how to create that one. So your center should be, give you a hint or a sketch on graphing this one because I don't have a perfect graphing paper or a graphing board here. So I'll just plot the negative 2, 0 here. Somewhere, let's say this is negative 1, negative 2. And I'll say, let's say somewhere here from here to here is square root of 11. I don't know if what are you going to use. It's either a ruler or any measuring device. So let's say this is how your square root of 11 look like. So you just have to put a string on this and clip this one, the end of the string, and make a circle out of it. So that becomes your circle. That's it. So another example that we're going to deal here is, let's say, find an equation of a circle passing through point four one with the center at negative 1, 0. This is a piece of a cake. Remember that you're given already a center, so you don't have a problem with the center anymore. Your problem is to get the radius, but again, the radius is the distance from the center to any point, and this is already the point, so you'll just get the distance from these points and this point. So this is -1 minus 4 squared plus 0 minus 1 squared. So I shall get square root of 25 plus 1, so I shall have square root of 26. So I have now my radius. So therefore, the equation of my circle here is x plus 1, because this is negative, squared plus y squared, because this is 0, so my k is 0, and this is 26 as the r squared. That's it. So it's up to you whether you have to simplify on this one with so much algebra, or you just have to stay as is. That's already done. Okay, let's consider another example of a circle here. I mean, another problem of a circle. Let's just say, find an equation of a circle passing through points let's say think of a point. Let's think of a point, let's say 1, 1. Let's say 3, 5, and 5, -2. So our problem here is we don't have a center, we don't have a radius. So what you have is actually 3 points on the circle. So if we are going to imagine that, let's say we pick a point here, we pick a point here, we pick a point here. Remember that this is the center. So suppose your center is HK. If you take the distance here and the distance here, they're both actually the same. If you take the distance here and the distance here, they're actually both the same. So in order for me to do that, I shall create systems of equation out from these 3 points. So let HK be the center of the circle. Okay. So, and let R be the radius. Note that R can be equal to square root of 1, R can be equal to the distance from the center to this point. So I have 1 minus h squared plus 1 minus k squared. So this will imply R squared equals 1 minus h squared plus 1 minus k squared. Another is I have R, which is the distance from this point to the center. So I'll have here 3 minus h squared plus 5 minus k squared equals R squared 3 minus h squared plus 5 minus k squared. Another is I also have this. So I have 5 minus h squared plus negative 2 minus k squared equals r squared equals 5 minus h squared plus negative 2 minus k squared. What happened? This means that this expression on the right side of this equation 1 is actually the same as the expression of the right side of the equation 2. And so with this is also the same as with this. So I can equate this as, or I can have, oh yeah, I can equate these two here. This expression is equal to this expression. And this expression, or either of the two, can be equal to this expression and solve for h and k. Something like that. You have to solve simultaneously. And you're just doing basic algebraic manipulation. And that's it. You get the hk. And once you get the hk, you get the distance from hk to any point here. And you'll get the radius. So I'm not going to show you this one because it's too long manipulation and my board is just small. But trust me, this is just basic. You're doing algebraic manipulation. If you have a question, you can message me on how to get this one. Okay, let's consider another example here. Find an equation of the circle with center that is 5 units away from y equals negative 2 and is found at the first quadrant. And one of the points of the circle, let's say, is at the origin. Okay, so question here is, find an equation of the circle with the center that is 5 units away from y equals negative 2 and is found at the first quadrant, and one of the points of the circle is at the origin. So let's say you have, where's the y equals negative 2 here? So let's say this is your line y equals negative 2. So it is found in the first quadrant, so you're pretty sure that the point, the center here is somewhere here. So 5 units away from y equals negative 2. Found in the first quadrant. So I can have a point here. 1, 2, 3, 1, 2, 3, 4, 5. So somewhere, this is your y here equals 3. So all points here are actually our choices of the center. So we have an infinite number of circles, so long as those points are found on the first quadrant. So this is actually, I'm sorry with giving you the example because I'm just thinking it now. I just thought it now. I'll just pick one equations from this problem because there are many answers to this problem. So I'll just pick 5 units away from equation y equals negative 2, so I can have, let's say, 1, 3. Because this 1, 3 is actually 5 units away from equation y equals negative 2, and it's found on the first quadrant. So this is now my center. So my center here is 1, 3. I can also have a center 1, let's say 2, 3. So anything that ends with, anything that has a value of 3 as the y coordinate, so long as those points are found in the first quadrant, are actually centers of the circle found on this problem. And the origin is at 0, 0, I'm sorry, and one of the points is actually at 0, 0, or the origin. So to get the r, I'll have the square root of 1 minus 0 squared plus 3 minus 0 squared. So I'll have 1 squared plus 3 squared. So I have square root of 10. Therefore, my equation of the circle is x minus 1 squared plus y minus 3 squared equals 10. So in general, on this problem, I can write the general equation of the circle on this problem as x minus h squared plus y minus 3 squared equals 10, where h is positive rational number, because you can have x can be 1/2, x can be 1/3, as long as it's positive. So that's it. Okay, that's all for now, and thank you so much for watching. So if you have a questions, clarifications regarding on this discussion, so you might want to comment down there. And I hope you will also subscribe through this channel in order for you to be updated on the next videos I will be creating moving forward. So up next will be parabola. Thank you so much, and God bless.